Welcome to another video solution by Kode. In this video, we will be looking at the add two numbers problem on LeetCode, and this video will provide you with the Python solution of this problem. I would be also making the C++ solution video soon, so I request you to stay connected with me to get the latest updates. So, without wasting any time, let's proceed to the problem. In this problem we are given two non-empty linked lists that represent two non-negative integers. The digits are stored in the reverse order. This means that the least significant digit is on the left side of the linked list and the most significant digit is on the right-hand side of the linked list. Also, each node can contain only a single digit. The objective of the problem is to return the sum of these numbers as a linked list. To understand better, let's check out the input sample 1. Here, the first number is 342 and the second number is 465. Adding these two numbers gives us 807. If we start adding the corresponding numbers from the left-hand side, we will see that 2 plus 5 is 7 and the carry is 0. So, we get 7 in the first node of the output. Then, we add 4 and 6 to get 10. This gives us a carry of 1 and the output node gets the value of 0. Moving on to the next and final node, 3 and 4 add to 7 and we also have a carry of 1 from the previous node. This makes the output node value 3 plus 4 plus 1, which is 8. Thus we get the output as 708 in the linked list. Now, let's head over to the Python code to solve this problem. The class representing each node of the linked list is commented in the top 5 lines. We have L1 and L2 as the input linked lists. As a first step, we create a new list which will store the sum of these two linked lists L1 and L2. We will be making use of a head pointer to create new nodes in the output linked list and return that later as an output of the function. In addition to this, we also initialize a carry variable to keep track of the carry from the previous steps. Let's start iterating over the linked list L1 and L2. This while loop will help us add the corresponding values in both the linked list. The reason we are using the logical AND operator is because for now, we want to traverse to only that length of the linked list where both of L1 and L2 exist, as the length of both the linked lists L1 and L2 could be different, as it is the third input sample. As a first step, we just need to add the values at only those positions where both of them are present. So, in val1 we store the value at the current position of L1 linked list and in val2 we store the value at the current position of linked list L2. The sum at these positions would be val1 plus val2 plus the carry from the previous step. After this, we will calculate the value of new carry and the actual sum that would be stored at the current position. To understand this better, let's consider the following example. If the sum at current position, that is, add 1 was equal to 7, then the value of carry would be 0 and the value to be stored at the current position would be 7. But, if the sum at the current position, that is, add 1 was equal to 15, then we will have 1 as the carry and 5 as the value that'll be stored at the current position. After doing this, we store current sum in the head pointer location and move both L1 and L2 pointer to the next position and repeat the entire procedure again. Once we come out of this while loop, at least one of L1 and L2 would have been completely iterated. So whichever pointer is not null, that is, whichever linked list has certain numbers still left, we are now going to iterate over those numbers and add them to the final linked list. The way we do that is same as we have been doing in the first while loop. We create a new head pointer, take the current value, add the carry from the previous step, then calculate the new carry and the sum at current step and update them to the final output linked list. Finally, after doing all these iterations over both the linked lists L1 and L2, it might be also possible that there is still a non-zero value still left in the carry and we also need to add that to our output linked list. In order to do this, we check if the value of carry is non-zero or not. If the carry is non-zero, we create a new node in the output list and add the carry value to it. That is it. Great job, and we are done with the solution. Let's try to run it and see if it works or not. And there you go. The solution has been accepted. I hope you liked the solution. If you did, then please hit the like button and press the bell icon to stay updated about the latest problems and their solution on LeetCode. Bye for now. Happy coding, and I'll see you next time with another exciting problem and its solution.